Hello, brothers and sisters. I'm going to make another video here. This one, I'm going to talk a little bit about significant figures and how to read a measurement with the correct number of sig figs. Okay, so explain how to read a measurement with the correct number of significant figures. So first, you're going to record the digits that are certain and one uncertain digit. You're going to make an estimate. All right. To do this, record the known digits that correspond to the graduation lines, then record the last digit by estimating between the graduation lines. So here's an example. We have a graduated cylinder here, and it's filled with water. We want to know what the value is. So we're going to record the digits that correspond to the graduation line. So the lines say that it's 15, 16, 17. It's more than 17 mils, right? This is in milliliters. So 17, and it's a little more than halfway up, right? So I would say this is about 17 point, I don't know, 17.6. Okay, oops, sorry. And so that last digit, the six there, that is our uncertain or estimated digit. So full sig figs, this would have 3 sig figs. All right. Okay, let's do a few here. Record the following measurements. Include the correct number of significant figures, proper units, and the uncertainty. Okay, so the length of strip of magnesium. So here we have in centimeters, this ruler has markings for every 1 centimeter, right? So we know it's at least 5, a little more than 5. I'm going to say that that's 5.5, and it's going to be plus or minus um, whatever our estimated value is, plus or minus 1 of what our estimated value is. So in this case, it's going to be a tenth of a centimeter. Okay, so it's going to be 5.5 plus or minus 0.1 centimeters. So you could have estimated 5.4 or 5.6. It would also be correct. All right, so now we're looking over here. In this case, we have measurements for every tenth of a centimeter, right? So it's kind of hard to see where that line is here. And so if I look really close, it looks like it's right in between here and here, right? So that's 5.1, 2, 3, 4. It's a little bit more than 5.4 and less than 5.6. So I'm going to say that's 5.5. Sorry, it's more than 5.4. So, and less than 5.5. So I'm going to call it 5.48. It looks like I would have probably gone with 5.45, but because it's kind of hard to see here. But anyway, it's plus or minus 0.01 in this case. So we had 2 sig figs here, and here we have 3 sig figs because we have markings for the tenth of a centimeter, right? Okay. Now we look at the mass of solid sodium chloride measured in grams using an electronic balance. So now we're given the full sig figs on these. These are already done. That last digit is already estimated by the balance itself. So this is 204.8 plus or minus 0.1. Okay. And this one is going to be 2.00 plus or minus 0.01. Right, so we have 4 sig figs here, and the uncertainty is at the tenths place. Here we have 3 sig figs. The uncertainty is in the hundredths place. So this balance is more precise than this balance because the uncertainty is smaller. It's 100th of a gram, whereas the uncertainty here is a tenth of a gram, right? Just like this ruler is more precise than this ruler because the uncertainty here is 100th of a centimeter, whereas the uncertainty here is a tenth of a centimeter. All right, hopefully that makes sense to you guys. Now, the volume of water measured in mils using graduated cylinders. So this one, we have 300, and so this is going 300 up to 400, so that would be 300, 310, 20, 30, 40, 50, 60, 70, 80, 90, 100. Yeah, so these are tenths of a mil on each line. So we're going to go 310, 20, 30, 40. Looks like it's more than 40, but less than 50. And it's really close to the top there. I would estimate that at 348 mils, plus or minus 1 mil. Okay. So we're looking at the bottom of the meniscus. Same thing here, the bottom of the meniscus. In this case, the bottom of the meniscus comes right to that line, but it's not like right in the center of it. So I'm going to say that maybe it's just a hair above it. So let's go with, so that'd be 7.1, 2, 3, 4, 5, 6, 7, 8, 9. Why don't we go 7.91? I guess what I had here is 7.90. It's right on the line, plus or minus 0.01. So hopefully that makes sense to you guys. So this is more precise than this one, because this one is has the uncertainty in the hundredths place, and this one has the uncertainty in the 1 mils place. All right. Now look at the temperature of water measured in degrees Celsius. So here we have two rulers that have the same exact measurements on them. It's between 20 and 30, right? So 20, it looks like 28, maybe 28 and a half. So I would go with 28.5. And it's going to be plus or minus a tenth of a degree. And then over here, we have, it's pretty much right to the line. So we'll call that 30.0. And that would be plus or minus a tenth of a degree as well. All right. Hopefully that helped you guys and it makes sense. If not, I apologize. But if you like this, if it gives you value, even if it doesn't, subscribe and leave me some comments. Let me know what you think. All right. Thanks a lot. Bye.